First of all, I would like to say a big thanks to all because our channel has reached 4K subscribers within a limited number of videos. So this is all because of you. Thank you so much for your love and support. Keep supporting our channel. So this is Dr. MK and welcome back to Ultimate Organic Chemistry. So in this video, I am going to discuss stereochemistry based multiple choice questions which were asked in previous year CSIR and CET examination. And if you are an M.Sc student or if you are preparing for IIT JAM, this video is going to be very much useful. Shall we start? Question number 1. This question was asked in CSIR December 2023. The question was, the structure that correspond to the following compound is. So they are given a cyclohexane in chair form. So this chair form of cyclohexane has to be converted to the corresponding planar form. So for that reason, I have given a planar form of cyclohexane. Now, in order to solve the question, initially we need to give numbering. So the numbering is given according to our convenience only, not based on the IUPAC nomenclature. So I have given the number from here. So 1, 2, 3 and 4. Now, and similarly you need to give numbering from here 1, 2, 3 and 4, right? So each carbon is considered as a plane, right? So now in this case, carbon number 1, the OH group is placed above the plane. So that means you need to draw in bold line. In second carbon, you can see here, so this methyl group is placed below the plane. So that means second carbon, the methyl has to be placed below the plane, that is dashed line. And in fourth carbon, you can see here, this methyl group is placed above the plane. So that means this methyl group should be drawn bold line. So this in this structure, OH group, first carbon OH group is present above the plane, second carbon methyl group is present below the plane, and fourth carbon methyl group is present above the plane. And if you check, this kind of structure is matching with, that is option C. So that's the right answer. Question number 2. This question was asked in December 2020 in CSIR. The absolute configuration at two chiral centers of minus camphor is. So they have given minus camphor and they have given number 1 and number 4, and you need to find out the RS configuration of both 1 and 4 chiral center. For that reason, I have given two structures. In structure 1, we will solve the chiral center 1 configuration, and structure 2 we will solve the chiral center 4 configuration, right? So let me see this first chiral center carbon. So before solving the question, you need to highlight the atoms which are directly connected to the chiral center. Now all the atoms are carbon. Now you need to look at the next atom which is connected to the carbon atoms. So if you look at this carbon is connected to an oxygen. So oxygen containing carbon should be given first priority, and the second priority should be given this tertiary carbon. Otherwise you can call it as quaternary carbon also. So this is third priority and this is having fourth priority. Now 1, 2, 3 groups are arranged in anti-clockwise direction. So anti-clockwise direction means the configuration is S, because the least priority methyl group is facing away from us. So whenever the least priority group is facing away from us means you no need to change the configuration. Suppose if the least priority atoms or groups is placed is facing towards us means you need to give the opposite configuration. Right, so this first chiral center configuration is yes. Now let us check the fourth chiral center configuration. And initially you need to highlight the atoms which is directly connected to the chiral center. So if that is the case, the first priority goes to this carbon because this is a tertiary carbon. And second priority, if you happen to look at here, so this is also CS2, this is also CS2. You need to look at the next atom. This is carbon, this is also carbon. But this carbon is connected to oxygen atom. So this is getting second priority and this is getting third priority and this will be fourth priority. Right, so now the 1, 2, 3 groups are arranged in clockwise direction. So the configuration is supposed to be R, but the least priority hydrogen atom is facing towards us. So that means this has to be strike out and you need to give the opposite configuration, that is S. So that is 1s 4s is the right answer. That means option D. Question number 3. In the most stable conformation of neomenthol, the stereochemical orientation of the 3 substituents on the cyclohexane ring are. So this is a structure of neomenthol. So this is neomenthol. And you need to draw this planar form of cyclohexane in chair form of cyclohexane. So let us give the numbering from here. Right. So that means this is first carbon, second carbon, third carbon, and fourth carbon. So the first carbon methyl group is present above the plane. So in this carbon, let us consider this carbon as a planar system. So above the plane group is, that is axial. So this methyl group has to be present in axial. And third carbon OH group is present below the plane. So at this carbon, the below the plane position is equatorial. And fourth carbon, if you look at, the isopropyl group is present below the plane, and in this carbon the below the plane position is axial. So this is one form, but they have asked it the most stable conformation. So that means you need to perform ring flipping of this chair form. So during ring flipping, the axial groups which are converted into equatorial, and equatorial groups will be converted into axial. So that means this is carbon number 1, this is 2, 3, 4. So the first carbon methyl group is present here at axial position, will be converted into equatorial, and third carbon OH group is present here at equatorial position. During ring flipping, it will be converted into axial, and fourth carbon isopropyl group is present at axial position. During ring flipping, it will be converted into corresponding equatorial position. So now always keep in mind that the non-polar group like methyl, ethyl, isopropyl, tertiary butyl group should be placed in equatorial position in order to avoid the 1,3 diaxial repulsion. So if you consider these two forms, in this case the non-polar methyl group is present at equatorial and isopropyl group is also present at equatorial. So this is a most stable form. So now the methyl group is present equatorial, OH group is present axial, and the isopropyl group is present at equatorial. So with this structure you need to answer. So now let us check. In option A, OH is present at equatorial, so this is wrong. And option B, OH is present at axial, yes, this is correct. Isopropyl group is present at equatorial, this is correct. And methyl is present at equatorial position, this is also correct. So that means the right answer is option B. Question number 4. The most stable conformation of 2-fluoroethanol. So this question was asked in CSIR June 2017. So they have given 4 conformers. Already I think this question is very much famous question. So directly we will go to the answer. So the right answer is option B. So because this OH group and this fluorine group, there will be intramolecular hydrogen bonding. Intramolecular hydrogen bonding. So whenever the intramolecular hydrogen bonding is taking place, so this will give the extra stability to the corresponding conformer, and this form will be the most stable. Right answer is option B. Question number 5. Among the following structures given below, the most stable conformation for the following compound is. So they have given the cyclohexane in planar form, and you need to convert this planar form into the corresponding chair form, and you need to find out which form is more stable. Fine. So you need to draw the 2 form of the chair conformation. So this is of carbon number 1, this is 2, this is 3, this is 4. Again I am saying, so this numbering is just for our convenience only. It is not related to the IUPAC nomenclature numbering. Now this first carbon methyl group is present at above the plane, and in this carbon the above the plane position is axial. And the third carbon methyl group is present above the plane, and in this carbon the above the plane position is axial. Now, the fourth carbon methyl group is present at above the plane, and at this carbon, the above the plane position is equatorial. Now, so this is present at axial, this is present at axial, and this is present at equatorial positions. Now, we need to perform ring flipping in order to find out the more stable form. And during ring flipping, the axial group will be converted into equatorial, vice versa. So now, during ring flipping, this is first carbon, second carbon, third carbon, and fourth carbon. And first carbon axial methyl group will be converted into equatorial position, and third carbon methyl group will be converted into axial to equatorial position, and fourth carbon methyl group will be converted into equatorial position into the corresponding axial position. Now, which is the more stable conformer? That is a question. And here two methyl groups are present in axial, and here two methyl groups are present in equatorial. Only one methyl group is present in axial. Here only one methyl group is present in equatorial. Fine. So I already said that the non-polar group should be present in equatorial, then only the corresponding chair form will be more stable, and if that is the case, the more stable form is this one. So you need to check with this structure the corresponding options. So that means the right answer is option C. Question number 6. This question was asked in CSIR June 2017. The question is, the most stable conformation of the following compound. So they have given a cyclohexane in planar form. So this cyclohexane contains two OH groups which are opposite to each other and two tertiary butyl groups which are opposite to each other. Now we need to find out which form is more stable. They have given all the four forms of this compound in corresponding chair form. This is chair form, this is boat form, and this is twist boat form, this is half chair form. Now we need to find out which form is more stable to the given molecule. So obviously when these two OH groups are present, you need to immediately look for the intramolecular hydrogen bonding. So in structure B, there is a possibility of intramolecular hydrogen bonding, and structure C, there is a possibility of intramolecular hydrogen bonding. But in both form, there will be torsional strain. So this will be less stable in nature. So when compared with boat form, this twisted boat form is more stable. So the right answer is option C, because so this form will have intramolecular hydrogen bonding between these two OH groups, and it gets extra stability. Right. So the right answer is option C. Question number 7. This question was asked in CSIR-NET December 2017. So the molecule has, so they have given a molecule, you need to find out which is the right answer. So this molecule has plane of symmetry, option A. So this molecule does not have plane of symmetry, you can perform it. And you need to find out the R or S configuration. This molecule has center of symmetry, this molecule has not any center of symmetry. So this will be optically active compound. So you need to find out the configuration is R or S. So for that reason, you need to look at the molecule from here, and you need to hold these two groups, and this will be giving you horizontal line. So at your right hand side, you will be holding COH. At your left hand side, you will be holding hydrogen atom, and you need to give priority based on that is Kahn-Ingold-Prelog's rule. So this will be having first priority, this will be getting second priority. And if you look at the back side, from here this part will be the back side. So at top you have COH, at bottom you have hydrogen atom. So you are already given 1 and 2 number, you need to give 3 and 4 number. So among these two groups, so this will be getting 3 and this will be getting 4. Now just ignore the fourth group. 1, 2, 3 groups are arranged in clockwise direction. The configuration is R. So the right answer is option C. Question number 8. So this question was asked in SET examination 2020. The most stable conformation of 5-hydroxy-1,3-dioxane is. So this is a straightforward question. So the most stable form is option A, because the reason is, so this hydrogen will be having hydrogen bonding with these two oxygen atoms. So this will be the more stable. Question number 9. The lowest energy. The lowest energy means most stable. Lowest energy means most stable form. Okay. In the lowest energy conformation of the compound given below, how many alkyl groups are present in axial position? So again, you need to convert this planar form of cyclohexane into chair form. So this is carbon number 1, 2 and 4. 1, 2 and 4. First carbon methyl group is present above the plane, and in this carbon the above the plane position is axial. Second methyl group is present below the plane. So according to this carbon, the below the plane position is axial. Fourth carbon isopropyl group is present below the plane, and according to this carbon, the below the plane position is axial. Now you need to convert this chair form into this chair form through ring flipping. So I already said during ring flipping, the axial group will be going to equatorial positions. So this methyl group is converted into equatorial position, and this methyl group is converted into corresponding equatorial position, and this isopropyl group also will be converted into the corresponding equatorial position. So you know that in second structure, all the alkyl groups are present in equatorial position. So this is a most stable form. Now we need to find out how many alkyl groups are present in axial. So there is no alkyl groups are present in axial. So the right answer is option D, that is 0, because all alkyl groups are present in equatorial position. Question number 10. The mesotartaric acid is achiral since option A, it has plane of symmetry in both the eclipsed and staggered conformation. Option B, it has center of symmetry in eclipsed conformation and plane of symmetry in the staggered conformation. Option C, it has a center of symmetry in both eclipsed and staggered conformations. Option D, it has a plane of symmetry in eclipsed conformation and center of symmetry in staggered conformation. So you need to draw the structure of the mesotartaric acid. So this is a mesotartaric acid, and this mesotartaric acid has to be converted into the corresponding Newman projection, right? So this is Newman projection, and if you do 180-degree rotation, you will get the other Newman projection form also, and this projection is called as eclipsed, and this is called as staggered. Now, so this Newman projection of eclipsed conformation can be drawn in corresponding Sagar's conformation, and this staggered form also converted into the corresponding Sagar's form. Now, in order to solve the question, you need to draw the both form of eclipsed and Newman staggered conformance of tartaric acid into the corresponding Sagar's form. Now, in eclipsed conformation, that is this one, this compound has plane of symmetry, and because of this reason, this eclipsed form of mesotartaric acid is optically inactive, that is achiral. In staggered form, if you happen to look at the molecule, from the middle of the molecule, if you draw a line, this line is meeting COH group. Exactly opposite to that, you have COH group. So that means this compound has center of symmetry. And you can also apply the same center of symmetry with this OH, also with hydrogen atom. So in both form of mesotartaric acid, that is both eclipsed and staggered form of mesotartaric acid contains plane of symmetry as well as center of symmetry. So this mesotartaric acid is optically inactive, that is achiral. Right answer is option D. So that means the eclipsed form has plane of symmetry and the staggered form has center of symmetry. Question number 11. In the following compound, they have given a compound and this is optically inactive, belongs to D family, optically active belongs to D family, optically active belongs to L family, optically inactive belongs to L family. Okay. So if you want to solve the question, you need to convert this Fisher projection into this one, because the most oxidizable group should be present at the top. So aldehyde is the most oxidizable group among the all the three groups. So this has to be present at the top. Now, so with this structure, we need to find out the answer. So first question, so whether the compound is optically active or not. So if you keep a plane, so this molecule has no plane of symmetry, no plane of symmetry. Also, this compound does not have no center of symmetry. So that means this compound is optically active. Right. So now the next thing is, you need to find out whether this form is D or L. And for the reason, you need to give numbering. And while identifying the D or L form, you need to look at the penultimate carbon. That is the last before one. The penultimate carbon OH is present at right hand side. It is present at our right hand side. So if it is present at right hand side, then the form is called as D form. Right. So the answer is, this compound is optically active. Also it has D form. Right answer is option B. Question number 12. The configuration of the double bonds in the following molecule are. Okay. So in order to solve the question, I have given the structure in 2 times. So in first structure, we will solve this double bond. The second structure, we will solve this double bond, so that we can avoid some kind of difficulties in giving the numbering. Right. So if you want to solve this double bond, just give the missed atom, that is hydrogen atoms. And you need to give priority in this side and in this side. At right hand side, the first priority goes to COH, second priority goes to hydrogen. At the left hand side, the first priority goes to the carbon-carbon double bond, second priority goes to hydrogen. Now 1, 1, 2, 2 are present in opposite side, so this form is called as E. Now in this second double bond, and at right hand side, you need to give the first priority to the double bond, because if you look at here, carbon-carbon double bond is there, followed by you have COH group. So this should be given the first priority, and the ring should be given second priority. And in the left hand side, phenyl ring should be given first priority, and cyclobutane ring should be given second priority. So 1, 1, 2, 2 are present in same side, so that configuration is Z. Now in order to solve this question, you need to give numbering from here. So the second carbon and fourth carbon geometry you need to give. So second carbon geometry is 2E, and fourth carbon geometry is 4Z. 2E, 4Z is the right answer. Right answer is option B. Question number 13. The relationship between compound 1 and compound 2. So these two compounds are given in corresponding chair form, and you need to find out the relationship between these two. So let me draw this chair form into the normal planar form of cyclohexane. So this ethyl group is present above the plane, and this methyl group is also present above the plane, and this methyl group is also present above the plane. This is structure number 1. Let me draw the structure of this compound also. So this methyl group is present. This is first one, this is second one, this is fourth one. So this is present below the plane, and this methyl group is present in above the plane, and this is also present in above the plane. Now this is structure of compound 2. Now you need to find out the relationship, that is diastereomer, enantiomer, conformational isomers, constitutional isomers. So they are not conformational isomers, because during ring flipping the stereochemistry should not change, so they are not called as conformational isomers. Now the question is whether they are enantiomer or diastereomer. If you keep a mirror backside to the molecule, and the mirror image will be the front side methyl group will go to back side, and front side methyl group will go to back side, and here front side methyl group will go to back side. So this is a mirror image, actual mirror image. And now if you compare this mirror image with these two, so this is not the mirror image of 1. So 1 and 2 does not have any mirror image relationship. Okay, so if a molecule does not have any mirror image relationship, that is mirror images that are superimposed, non-superimposable means they are enantiomers. Neither mirror images nor superimposable are called as diastereomer. So this compound 1 and 2 relationship, that is diastereomer. Option A is the right answer. Question number 14. The correct molecule having the absolute configuration as S 4-bromo cis 2-pentene is, right. So they have given a clue, that is the double bond geometry is cis. So that means the hydrogen should be present in same side. So here the double bond geometry is cis. Here the double bond geometry is trans. These two hydrogens are opposite, cis and trans. So with that, option B and option D are ruled out. Now you need to find out the configuration S, RS configuration of both chiral center. Okay, for the reason here you need to give a numbering. This is first priority, this alkene will get second priority, this methyl group will get third priority, this will be getting fourth priority. Now 1, 2, 3 groups are arranged in anti-clockwise direction. Least priority group is present backside, no need to change the configuration. Anti-clockwise means the configuration is yes. So that means yes, cis is the right answer, that is option A. And if you want to solve this one, I'll solve. So this is 1, 2, 3 and 4. 1, 2, 3 are arranged in anti-clockwise direction. The least priority hydrogen atom is present front side. So it's supposed to be yes, but it is not the case. It is R configuration. So right answer is option A. Question number 50. The number of stereoisomers of a compound is given, which is having double bond as well as a chiral center. And you need to find out the number of stereoisomers. So if you want to solve the question, you need to redraw the structure in this way. Because if you want to find out the number of stereoisomers, you need to consider both the chiral center as well as the double bond as stereo center. Okay, so for that reason, so this carbon is a chiral carbon, and this double bond is also considered as a stereo center. But this double bond should not be considered as a stereo center, because this double bond has both methyl group which are same. So this double bond cannot produce geometrical isomerism. So we cannot consider this double bond as a stereo center. So the number of stereo center n value, that is 2, and the compound is unsymmetrical. If the compound is unsymmetrical, then the number of stereoisomers equal to 2 power n. So that is 2 power 2. 4 isomers is the right answer. So the right answer is option A. That's all. Right, so I hope these stereochemistry based multiple choice questions are very much useful to you. And if you find so, you can like the video, share your opinion in the comment section. Do not forget to subscribe our channel. And I will meet you all in the next video. Until then, take care. Bye.